Hi, and welcome to Chapter 2.4, Chemical Reactions. Okay, we've been talking about matter, and we've been talking about its form, substances and mixtures, and substances are elements and compounds, and mixtures are homogeneous mixtures or solutions, and heterogeneous mixtures. Now we're going to see how all these things work together. All right, have you ever seen a match burn? What do you think is happening? A chemical change or a physical change? Keep that thought in mind, and we'll be back to talk about it later on. What always happens during a chemical change? There's a change in the properties of the substances that we have been looking at. So there are key words we use when we are talking about if a chemical change has occurred. So if something burns or rots or rusts or decomposes or ferments or explodes or corrodes, these words signify that a chemical change has occurred. So the ability of a substance to undergo a specific chemical change is called a chemical property. Okay? So iron will combine with oxygen to form rust. We know that iron is a metal, and it's kind of silvery in color. Oxygen is a gas, and rust is kind of a reddish color. So we have different colors to tell us that a chemical change has occurred. So the ability of something to rust is itself a chemical property. So basically, rusting is the oxidation of something, where you're adding oxygen to it. Chemical properties can be used to identify a substance. But these properties only are observable when the change occurs. Okay, so the substance has to undergo this change to determine what the properties are. For instance, let's look at carbon. If we have a big chunk of carbon and we grind it up or break it up into smaller pieces, it's still carbon. Okay, it's not been changed. It's just been physically ground. It still has carbon elements in it, okay? So the key word here is in a physical change, the composition never changes. Okay? Physical changes, composition remains the same. So what do you think about chemical changes? Yeah, the composition changes in chemical changes. Okay, so here we go. In a chemical change, composition always changes. So let's look at charcoal. When we burn the charcoal, it reacts with oxygen, okay, and it forms other substances. So therefore, a chemical property of charcoal is that it can burn in oxygen. So what is another name for a chemical change? Yes, a chemical reaction has occurred. So whenever we have one or more substances changing into new substances, we have had a chemical reaction. a substance present at the start of the reaction? This is easy. It's called a reactant. And something that's produced is a product at the end of the reaction. So we have reactants in the beginning, products at the end. So the reactants in the burning of charcoal are carbon and oxygen, and one of the main products formed is carbon dioxide, which makes sense. So carbon plus oxygen produces carbon dioxide. You know, this pen was working so well, I don't know what's going on with it though. What is always true of a chemical change that is never true of a physical change? Okay, we've been saying this. Chemical change, composition changes. Physical change, never. Composition never changes. Okay, here's some clues to use to determine if a chemical change has occurred. Now, they're clues. Usually, they're very good clues. Sometimes a physical change may have similar clues, so you have to be careful. Okay, so what are these 4 clues? Okay, the first thing is there's usually a transfer of energy. So maybe it's absorbed some energy or it's released some energy. Oftentimes there's a change in color or bubbles or precipitate. Now precipitate, remember, is when a solid comes out of a liquid. So let's think about cooking. When you burn natural gas, it releases energy which is absorbed by the pan and the food. So we have the methane. Oops. The methane is what natural gas is made out of. It combines with oxygen, so it burns. Energy is given off in form of heat and light. And some of this energy is transferred and absorbed by the food, cooking it. Okay, so we see some changes in the food. So we may brown the food, which is a change in color. So the meat or the food is getting changed. Okay, there are other clues too. If you're cleaning a bathtub and you have the scrubbing bubbles. So soap scum, yuck, is a precipitate that's left on the tub that you want to clean. I already told you what that was. So some bathroom club cleaners will start to bubble. And it's because a gas is released during the chemical change that is taking place in the cleaner. Okay? Now, these are clues, but it's not a certainty. Okay? You cannot be certain. And this is a cautionary tale. It could be a result of a physical change. What do I mean by that? Well, if you boil water, you are transferring energy from the heater to the water. There is an energy transfer from one state to the other. You require heat to change it from liquid to gas. You also might see some bubbles when it's boiling. Or if you open up a Pepsi. Okay? Still no reaction has occurred. It's just that you've released pressure and the bubbles come out of solution. So It's something you could see, but it might not always be there. It's a clue. It's not the be-all, end-all. What you have to do to determine if it really was a chemical change is test the sample beforehand. Know what its composition is beforehand and then after. Are they different? Then you know you have a chemical change. Okay, so for instance, if I take an antacid tablet and put it in water, I produce carbon dioxide. So that's one clue that a chemical reaction occurred. If I take litmus paper and dip it into a solution and the color change, it could be due because of the acidity or the basicity of the solution, or the pH. Okay? So it reacts to the acid or base. If something comes out of solution, if you're making cheese, one of the things you have to do is separate the solid curds from the liquid whey. So that you can make your cheese. So let's go back to our match. Do you say chemical? You're right if you did, because there's a transfer of energy in the form of heat. You have light, you have a change in color, and the composition of the materials change. Okay? See the carbon there? What's the only way you can determine if a chemical change has taken place? You must test the composition before and after the change. Now we're going to talk about a law, conservation of mass. How are the mass of the reactants and the mass of the products of a chemical reaction related? If we burn wood, we end up with a small pile of ashes. If we put that on a balance, the ashes might not weigh as much as the wood did. Why? What else was produced? Smoke, gas. So those things are no longer in the pile of ashes, but they've been dispersed. But they have mass also. If we were able to collect the smoke and gas and weigh that too, we would have exactly the same mass. So the law of conservation of mass is basically saying during a chemical reaction, the mass of the products is always equal to the mass of the reactants. Number one rule, you have to have the same things that you start with. They can be rearranged, but they are still the same thing. Okay, so this summarizes what I just said. Okay, however, this is not just for chemical reactions. If you have 10 grams of ice and you melt it, you'll have 10 grams of water. It just doesn't go away. It's conserved. So this is where the law of conservation of mass comes from. Take this down as a note. In any physical change or chemical reaction, mass is conserved. The mass of the products equals the mass of the reactants. The mass of the starting material equals the mass of the ending material. Mass is neither created nor destroyed. There's a finite amount of mass in the universe. Okay? Now we'll learn a little later, Einstein has broadened this with his theory because now energy equals mass times some constant. So energy and mass can be converted into each other, so sometimes this law will be changed to the law of conservation of mass and energy because it's not being created or destroyed, but it could be turning into energy. Usually we're talking about that at a much higher level. Now we can see this much better, if we have closed containers, because then all the gas does not escape. So there's our two vials. We mix them together. We still have the same mass if we look at the scale. To what changes does the law of conservation of mass apply? Chemical changes and physical changes. Summaries. Here's your notes. Stop the video, take these down. And remember, different forms of matter may undergo physical or chemical changes. That's it for slide 2.4. See you in class.